Hey, what's up guys? Quick video here to go over this display here that I put together. It's actually one of these 4 7-segment displays in one package from SparkFun. It's kind of cool, and I'm controlling it all using transistors, a single shift register, and and one of these binary to 7-segment display driver chips, and we'll go over all of what's going on here in a second. But the reason I'm making this video is because I think this is a really good way to control 7-segment displays without losing your brightness and flicker, you know, because I am multiplexing this display, and and I'll show you what that means here in a second. In fact, let me do something here. I'm going to slow this down just a hair, because if you're unfamiliar with multiplexing, it's worth seeing how it works real quick here. So I'm going to slow down the multiplexing effect. Let's see if I can upload that to the board real quick. And basically what multiplexing is when you look at the display, you're only seeing one LED on at a time. But we turn it on so fast, turn things on and off so fast that to your eye, it looks like everything's on at the same time. So right away when you look at this, and I just slowed down the delay, instead of lighting up each individual segment in each display, I'm lighting up the entire display in each of the 4 displays, if that makes sense. So instead of going LED by LED, if I did that, I would lose a lot of brightness, and if I did want to achieve some kind of brightness, I would get a flicker effect. So basically that's what we got here. So it only needs 3 pins off your microcontroller, 1 for data. I have a video on shift registers because you might want to take a look at that before watching this, because this might not make sense. Crap, screwing this up. But yeah, you need a pin off your Arduino for data, a clock pin, and a latch pin. Okay? So anyways, let's get started. So there's a lot of transistors going on here, nothing to be scared about. It's pretty easy. So right here is sort of a schematic, I guess. And I'll take a picture of this and put it up on my website. And we'll go over the code too. So anyways, let's just work our way down here. Here's the actual display, and there's 4 displays, I guess 4 7-segment displays in a single package. And what they've done was, the first display, we'll call that the thousandth digit. All of the anodes are tied together, so there's 7 segments in that display, but they tied all of the anodes together. Okay, this is the hundreds place. This would be the tens place, and then this is the ones place. Alright, so all of the anodes are tied together for each display, and then what they've done was tied all of the cathodes together for each A, B, C, D, E, F, G segment. So it's kind of confusing. They call this a common cathode display. So the A segment of the thousands, hundreds, tens, and ones is all tied together. So you're left with an A, a single A pin, a single B pin, C for all 4 digits. So you have to, if you want to work with this display, you do need to multiplex it. There's no way around it. Or maybe use a special driver chip. Okay, so what we got here, and this is kind of confusing because a common cathode means that you have to supply power up to the anodes and then ground the segment that you want to control. Oh, and I just realized I'm missing a little resistors in here. Okay, but anyways, let's go through this anyways. And I do have these pins marked here, but you can look up Google the schematic for it. So let's get started. I probably already wasted a ton of time talking about this. So anyways, we have 5 volts connected to 4 transistors here. The collectors are tied directly to 5 volts, and these are NPN transistors, 2N3904. I have that marked up here. Transistors, just standard run-of-the-mill stuff. The base is connected to a 1K ohm resistor, And basically I'm using these as a switch, so when you drive the transistor's base high, you get current flow from the collector to emitter, and it's kind of just like a little switch. So I have each 4 of those tied to a transistor. Then it would go through each one of the displays, and then each one of the A, B, C, D common cathode connection is tied to another collector through a transistor. But there's also a little 330 ohm resistor here just for the current limiting of the LED. Okay, so let me just go through how you would actually control this. So if you wanted to light up the if you wanted to light up the first digit here in the thousands place, when you look at it, what's happening is this transistor goes high, enabling this one current flow to flow through any of these segments, and then you can light up all of the actual segments then to whatever number you want, right? And what I'm using to drive each one of these is this CD4511 chip, which takes binary numbers in and then outputs. It's designed to be used with 7-segment displays. So it has the A, B, C, D, E, F, G. And this will drive 7-segment displays, but because I have to ground these pins, that's why I'm using these transistors. Otherwise, I could just drive them directly. So I have to use these transistors to ground the cathode. Okay. So this chip has all of these 7 segments here outputted, and it inputs the binary numbers. So you have A0, 1, 2, 3. So it's just 4 bits, gives you basically 0 to 9. That's all you would ever go up to on this anyways. Okay. Then we have a shift register over here, and what this does is it controls the binary input to the CD4511, and it enables each one of these anodes here. So it's, I guess we could call this, the enable, I guess you could call it that. So if you just go through this here, I have the pinout here a little bit. So the data is connected to pin 4 on the Arduino. The clock pin is connected to pin 2 on the Arduino, and then the latch is connected to pin 3 on the Arduino. Let's see. So, and the shift register is an 8-bit shift register. So you have 8 parallel outputs. So you have on pin A here, which is the first bit inside the shift register, is connected to A1 here, and then B is pin A2, 4 is, D is on 4. Where am I at here? 3, 4. Oh, never mind. This is actually so 1, 2, 3, 4. That goes up here, A, B, C, D. Sorry, I was thinking that these go to the CD4511. So the bottom 4 bits of this shift register control the enable pins, and then the top 4 bits control the CD4511. Okay? So you have to, and this might make more sense when we get into the code, but I just wanted to touch on this. And basically what we're doing is doing this, what I'm showing here, very quickly. And it seems like it's a really good way to control 7-segment displays. And this will eventually make it onto the Geiger counter. So I think that's good for now. Let's go take a look at the code and see what's going on. Okay, so let's take a look here at the code. It should be fairly straightforward. Let's go all the way up here to the top. Okay, so the first thing we do, like normal, we set up some variables. No big deal there. We defined the latch, clock, and data pins all as outputs. And we write the latch low just for starting out. We do a serial.begin. Okay, we're going to use I use the serial monitor for this code just to verify that I was breaking up the number into the different placeholder values. We'll get into that a little bit more here. So in the main loop here, there's nothing really going on. Everything kind of takes place in this 7-seg subroutine, and we're using this integer number as the display. So we're going to display number. And then it goes through, displays it, and then it comes back and either adds 1 to it or subtracts 1. So it counts up to 9,999 and then counts down to 0, and then just keeps doing that back and forth. Okay, so let's jump into this subroutine and see what happens. So here it is. It comes in, comes in as an integer, this input number here. We have, I'm not sure if this is exactly right, but I'm declaring these variables as shorts, and I think that's a 4-bit number. It doesn't really matter for what I ended up doing, but anyway. Because what we need to do is take this input number, which could be any number from 0 to 9,999, and we need to split it up into the different digits, and that's kind of what takes place here. I wasn't going to go into that much, but whatever, we can if we want. So let's say you have the number, let's just say our number is 1234, so 1,234. The first digit is the thousandths place, or is the thousandths digit. So in order to break that away, which is the number 1, we just simply take the integer of the input number divided by 1,000. And then that gives us 1. So that's pretty easy. Don't worry about this yet. I'll come back to that. To get the hundredths place, we divide the number by 100. So if we took 1,234 and divided it by 100, we would be left with 12. Okay. Then what we do is take 12, and then this is where things get a little bit complicated. We take 12, and then we divide 12 by 10, right here. That would give us some number, but since we only care about the integer value of that number, we get 1. Then I multiply 1 times 10, and that gives me 10. So we take 12 minus 10, and that gives us 2. So we have the hundredths place as 2. Okay, so that's a little bit of convoluted, goofy math going on there, but it works. Then we look at the 100, and then we do some things here. And I'll get back to what this is here, this little bit shift. The tens place, same exact thing. We instead of dividing by 100 or 1,000, we divide it by 10. So if we had our number as 1,234, we get 123 from this, so 123. Then we take 123 minus, 123 divided by 10 again, and then times 10. So let's see, that would give us 12 if we divide it by 10. Then times 10 gives us 120. So 123 minus 120 gives us 3. So it works perfectly. And then when you get into the ones place here, it's the same exact thing. But instead of that second part here, we have to actually, I don't know why I keep doing that. Instead of doing this second part, see, I cannot figure this out, why it shifts like that. Anyway, I forgot what I was even talking about. But yeah, instead of doing this part here, dividing, we don't have to because we already are at, the bottom level. We don't have to divide 1, 2, 3, 4 by any number because we need that. We're trying to get the 4 out of 1, 2, 3, 4. So we just take 1, 2, 3, 4 minus, we shift the whole thing down and then up 1, and that's kind of how it works. So we divide 1, 2, 3, 4 by 10. That gives us 1, 2, 3. And then we multiply by 10. That gives us 1, 2, 3, 0. So 1, 2, 3, 4 minus 1, 2, 3, 0 gives us 4. And then we do the bit shift thing again, which will make sense in a second. All right, and then if we just look at here the serial monitor, I actually decided to, wait, I don't know what's going on here. Oh, this isn't going to work in this code. I was doing this early on, but since I do this bit shift here before actually displaying the numbers, it doesn't work. So forget that part of the code for now. In fact, what I could do is move it. When I post the code online, I'll make this so it does work. This little part of each one of these needs to be moved past the serial print of all the numbers. Okay, so continuing on here. Oops. Let me just try to get that in the window there. Okay, so then we get into the point where we actually do the shift register part, where we actually shift these numbers out and display them. Okay, so here's, I guess, where things will get a little confusing. This is where we need to encode the which digit we're going to enable and the value that digit will display. Okay, and in order to do that, we need to encode the enable part or enable pin that we want to control inside of the number, and that's what this bit shift thing is here. So what I'm doing actually here is I'm moving the number thousands. So in this case, it was 1, 2, 3, 4. So we have some number 1. I'm moving it to, if we said this was a byte, we're moving it to the left 4 times. So it's held in the upper 4 bits of the byte, and then we add 1. So what the 1 is that's the enable pin, which is going to be stored in the bottom 4 bits of the byte that we're going to shift out to our shift register. So if you notice, this is 1, 2, 4, 8. So that's telling you that we have 4 bits there, 4 pins outputted. And when, if you look at a binary 1, this is basically 0, 0, 1 like that. And then this is 1 like that. So, I mean, these are just pin outputs. And these drive those anode powered transistors. Okay? And same thing for the 4 and 8. So that's in the bottom 4 bits, the enable pin, and then we store the number in the upper 4 bits. That way, when we shift out here, so what I'm doing, let's just go right into this. Basically, this is the thousandths position. And if the number isn't greater or equal to 1,000, that's why I have this little if statement here. I don't even want to bother turning that digit on. What's the point? It would be a waste. Otherwise, it would just display at 0, and I hate displays that do that. So that's why each one of these has this little if thing. So if it's not there, don't display at 0. Okay, and let's look here. So the first thing we do is write the latch pin low. Then we shift out let's see how this works. This is pin 4. Oh, I have it right here. Is the data pin. The second number is the clock pin. And then you have to tell it which way you want it to shift it out, either the most significant bit first or the least significant bit first. And we're going to shift out the most significant bit first. Okay? And we shift out thousands. So the upper 4 bits is the actual number, and the bottom 4 bits is the enable pin, the enable position, so which digit you want. Okay? And then you write the latch pin high. And I slowed this down before, and I made all these 500 milliseconds. But I'm actually running it very, very brightly with no flicker at 5 milliseconds delay. So it writes it, and it holds it for 5 milliseconds. Then it writes the tens place. Then it writes, the thousand. I don't know why it keeps doing that. So it does thousands, hundreds, tens, and then the ones place. And I actually had a little for loop in here just in case I wasn't sure if I was gonna get any flicker effect. So I was gonna actually just sort of, loop this for a few times. But anyways, it turned out I didn't have to do that. So I'm basically going to port this code over to the Geiger counter as soon as I get this display on a proto board. So that's how the code works. Simple enough. So hope that helps. It's just I know there's better ways of controlling these displays, but it's just another another way to do it. So thanks for watching.